Welcome to solverfy.
The equation for magnetic force is given by F equals to Q times cross product of velocity and magnetic field. Now let's do the cross product now. So this will be equal to 1.05 times 10 to the power 6 meter per second, and the cross product of the components x, y, and z components. So let's do that. So this will be 3 I cap times 0.12 Tesla K cap, and so on. So to simplify, we can multiply the magnitudes of the components and then take a cross product of just the unit vectors. So this is gonna be equal to 0.12 Tesla. Let's write that down. So basically, I'm writing here the magnitude of the magnetic field, and this will be negative 3 I cap cross K cap plus 4 times J cap cross K cap plus 12 times K cap cross K cap. Now we know that this is gonna be 0 because these are parallel, and I cap cross K cap is negative J cap, and J cap cross K cap is I cap. So we write that over here, and we get the force to be equal to so basically I have multiplied these two values, and we have plus 3 J cap plus 4 I cap from here. So now we can find the magnitude of the force. So that is going to be equal to Q times negative Q times 1.26 times 10 to the power 5 Newton per second, and the magnitude of this. So that we find from Pythagoras theorem. So that is going to be 3 square plus 4 square and root over of that. And we get this magnitude of force to be Q times 1.26 times 10 to the power 5 Newton per coulomb times 5. So from here we can find the charge, which is gonna be force over this factor. So that will be 5 times 1.26 times 10 to the power 5 Newton per coulomb, and there's a negative sign. And we get the magnitude of charge to be negative 3.89 times 10 to the power minus 6 coulomb. Now for the second part, we are gonna use Newton's second law to relate force with acceleration, and we know that the summation of all force, or you can say the net force, is equal to mass times acceleration, and this gives A equals to the magnetic force over him, which is the only force in this case. And from here we can write A vector equal to, so we are going to use the force that we found here. So that is equal to Q times this value, and we have already calculated the value of Q. So that is equal to here this value. So we use that and we get this value to be 0.49 meter times 3 j cap plus 4 I cap. So this value is basically the multiplication of charge and this part over here. And we have mass, so which is given to be 2.58 times 10 to the power minus 15 kg. And we solve this equation and we get the acceleration to be 7.6 times 10 to the power 14 meter per second square I cap plus 5.7 times 10 to the power 14 meter per second square j cap. So for the third part, so we know that the force is in the xy plane because velocity, because the magnetic field is in the z plane and force is perpendicular to uh, the magnetic field because of the cross product. So that's why the force is going to be in the xy plane, and due to that the z direction the particle moves with constant speed, which is over here. So the speed in the z direction is basically this value times this, and this is going to be constant because there is no force in the z direction. And in the xy plane the force F causes the particle to move in a circle with the force directed towards the center of the circle. So you can say that in xy plane the force is going to be a circle, but because of the velocity in the z direction, the superposition of both of these will give a helix. So the particle moves in the circle because of the force of the due to the centripetal force, and due to the constant velocity in the z direction, it keeps on moving forward in that direction, and we get the helical path. Now to find the radius, let's use Newton's second law, which is net force is mass times acceleration. And since the particle is moving in a circle in the xy plane, this A is going to be centripetal acceleration, which is given by v square over r, where r is the radius that we are going to find. And this gives r to be equal to mv square over the magnitude of the magnetic force. So let's find first the velocity, the magnitude of the velocity. So this is going to be equal to vx square plus vy square. We don't need vz square over here because the velocity in the xy plane, uh, because the force is in the xy plane and the centripetal motion, the linear velocity is only due to x and y components of the plane. So this gives the magnitude of velocity in the xy plane to be 2.756 times 10 to the power 13 meter per second square, and the magnitude of force is already given to be 2.45 Newton. Now we just plug in these values into this equation and we get the radius to be 0.029 meter. For the last part, we have to find the cyclotron frequency, and we know that this frequency is equal to omega over 2 pi, and omega is basically equal to the velocity, tangential velocity over radius. So this gives the frequency to be v over 2 pi r. and we already found the tangential velocity in xy plane over here. So we are going to use that, and we know the radius, which is equal to this value, and we get the frequency to be 2.88 times 10 to the power 7 hertz. And so omega will be equal to 2 pi f from this equation, and this is going to be equal to 1.81 times 10 to the power 8 radians per second. So for the last part, let's find the time period in the xy plane. So this is going to be equal to the inverse of frequency, and that is equal to 3.47 times 10 to the power minus 8 seconds. So we are given that at time t equals to twice of time period, the particle has returned to the same x and y coordinates, and the z component of the motion is motion with a constant velocity vz, which, as we said, is equal to this times this value. So let's use the kinematic equation over here. So this is equal to c over z naught plus vzt, and the initial value of z naught of z is equal to 0, and we get this value of c to be positive 0.874 meter. So this is the position of the particle in the z direction. So the coordinates of the particle at t equals to t 2t will be, so writing it in this format will be, so x is basically equal to r initially, which is 0.029 meter, y is 0, and z is the value that we found over here.